Okay, YouTube, in this video we're going to focus on how to solve an absolute value inequality. So in the past, we have looked at solving absolute value equations, and what we discovered was if we had any statement like this, x, the absolute value of that is equal to c, where c is some real positive number here, then we would say that we would just basically rewrite this. And the first way we would rewrite it is x is equal to c. We would just kind of leave it the same. And in the second instance, we would say, well, x is equal to, so nothing changes on the left, but negative c, where c is some positive number to begin with. So we'd rewrite it and then get x by itself. Solving an absolute value inequality is really kind of the same thing. The only difference here is that we're going to have to talk about this inequality sign, but it says if u is an algebraic expression and c is some positive number, then we say the solution of the absolute value of u is less than c are the numbers that satisfy that u is between and not including negative c and c. So one thing I want to mention here is this. What they're really saying here is if we took u as less than c, if I rewrote this, so I'm rewriting it now, and the two ways I rewrite it are these. We'd say, well, then u is less than c, we'll drop the absolute value bars and keep it the same. But I'll also mention this where we'd say u and make the right side negative, but I also need to switch the inequality sign. We would say that this is the second way of rewriting it. What I want us to consider, though, is that in either instance, u is the same thing. And for me to write this way would be the same thing as for me to write this negative c is less than u. And if I were to put this here and I say u is less than c, I would say, but also less than c. You can see how these two things, this here, this compound inequality, means the same thing as if I had rewritten it these two ways. So I would suggest rewriting this the first times you are doing these to get used to it. But basically, we would say that if this is a less than, we say c is always bounded, or sorry, u is always bounded by positive and negative c. Now we say the solutions of the absolute value of u is greater than c. If I say let's do this, let's rewrite this, greater than c. We would say the two ways I would rewrite it are u is greater than c, and I would say u is less than now negative c. So I switched my middle sign, I made the stuff on the right negative. In this case, I have to write or, because if I said u is greater than this positive c, that could be like u is greater than 4, but also u is less than negative 4, I can't tie these together like we tied these together. So we would say either u is less than negative c or u is greater than c, which was like the original statement. So what you're reading here, it says these rules are valid if we replace the less than or greater than by less than or equal to or greater than or equal to. That just means that if I had had a greater than or equal to here first, these two would have been greater than or equal to. And then if this was greater than or equal to here, then these would have been also or equal to. So let's take a look at these three examples that I provide us with here. So it says solve and graph the solution set on a number line. We have x minus 2, the absolute value of that is less than 5. So the first thing I notice is that I need to get this absolute value quantity by itself, and I notice that we don't have any numbers out front, and I don't have any constants that are being added on to the end. So since it's already by itself, what we're going to do is we're going to rewrite. Now, I notice that this is a less than relationship here, which means that this x minus 2, if we were going to rewrite it as they have it up top, we would rewrite it thusly. We would say less than positive 5, greater than or equal to negative 5. So this is our compound inequality right here, and this is what I really want to shove everybody towards. But for now, if you're really struggling with how that's true, then we'd say, well, then rewriting this, let's do this. We say x minus 2 is less than 5 is the first way we shall rewrite it. And the second way we rewrite it is x minus 2 is, instead of less than, we'll put greater than. And instead of a positive 5, we write negative 5. So we could solve both of these right now. I mean, if I said add 2, add 2, add 2, add 2, what I want you to see is doing it this way, which is not the way I recommend, but way that always works here. We end up with a solution set that says x is greater than negative 3 on the right, but x is less than 7 on the left. So if I said x is some number that's less than 7 but greater than negative 3, then really, looking at this inequality on the left, if I had just added 2 to everybody here, you would see that I get negative 3 is less than x is less than 7. And so this is the same statement. These are the same things. Okay. What we need to do now is go graph it. So putting this on the number line, looks like if I put maybe 0 here, I go 1, 2, 3, 4, 5. I need to go out to at least 7, so I'll head up to 10, and I'll go back to negative 5 here. 3, 4, negative 5. We would say that we're not including negative 3, which is this number right here, and we're not including 7, but we're saying that x is all numbers in between these. And that would be the set of numbers that satisfies this original relationship here. So in set notation, in interval notation, pardon me, we'd say from -3 up to and not including 7 right there. It's the same thing. So now looking at checkpoint 9 here, one thing I want to point out is that we have a +20 and a -3 in front of this absolute value. So before we do any rewriting, we're actually going to need to isolate that absolute value, get it by itself. So now we have -3 times the absolute value of 5x minus 2. And we would say is greater than or equal to, now -19 minus 20 more would be -39. And so now we're going to divide both sides by this -3 out front, which will totally get rid of that for us. One thing to keep in mind, however, is that we just took an inequality and we divided by a negative. So we would say we need to switch this sign right here. And that's one mistake a lot of people make. We say this becomes a +13 on the right. So now noticing that this is a less than relationship here, again, I'm going to notice we get this compound inequality where this middle expression is trapped by negative and +13. So I am going to rewrite this as I would want anybody to rewrite it, which is 5x minus 2 is less than or equal to +13, but greater than or equal to -13. And rewriting this both ways gives you the same statement here. I just know that this is the way that is preferred, and it's a lot quicker, honestly. So we would say, operating on everybody here, we say 5x is bounded between 13 plus 2, which is 15, and -13 plus 2, which is -11. So now we're going to divide everybody by a +5. So dividing by a +5 here. I'll actually work with decimals on this one. I actually don't have a problem with that. We say 3 on the right, but over here we would get, it looks like 2.2. And so now we need to sketch this on the number line here. So our number line would look like this. We'd say here's 0, 1, 2, 3, 4, 5. And we would say that 3 is right here, 3, and here's 2. So between and including 2.2 and 3 would look something like this right here. And this would be our set of solutions right there. And in interval notation, we say from 2.2 and including 2.2 up to and including 3. So now this last example, you'll notice that it's written a little bit backwards than what we're used to. We're used to having the absolute value on the left. So if it makes you more comfortable, let's switch this back around. We say the absolute value of 6 minus 3x. Notice that it's actually greater than this 18. We need to switch this around, switch everything around. So because the absolute value is already isolated, what I'm going to do here is I'm going to rewrite this two ways. And because it's a greater than relationship this time, I notice that it's going to be one or the other. It's not going to be trapped here between positive and -18. So the first way we'll rewrite this is just dropping the absolute value bars. 6 minus 3x is greater than 18. This is the same. And then over here when we rewrite it, we say 6 minus 3x for sure, but we'd say is less than, and we have to make what's on the right negative. So I like solving these because, you know, it's the same thing across the board here. We're going to subtract 6 from all of these instances, and we get left with -3x has to be, in this case, greater than 12. And over here, we get these cancel. We get -3x happens to be less than, looks like a -24. So our last maneuver here would be to divide everything by a negative, and specifically -3. So we're going to switch our inequality signs over. So these cancel. We get x is now less than -4. Put a box around that. And we say x is greater than. We had to switch that around. 8. So now, sketching this on the number line, the thing is, what we're saying is it's greater than +8 but less than -4. So what this means is it's going to kind of diverge. They're going to go out to the sides, the solution sets here. Excuse me. 1, 2, 3, 4, -5. This will be sufficient. So -4 is right here. And then we would say a +8. +8 is over here. So we say greater than 8, not greater than or equal to. So we say all of these numbers over here, as well as all of these numbers, not including 4, but to the left of 4. So when we write this in interval notation, the weird thing is you can't write an interval that's kind of broken up into two different intervals unless we union them. So to express this in set notation, or I guess interval notation, we would say from -infinity up to -4, not including 4, in union with 8 to infinity. That would be our set of solutions right there. Cheers.